We are live now. I saw myself on YouTube. That was funny. Sagar, since you need a little more time, than as we had discussed on WhatsApp, maybe you want to get started, and
Yeah,
so
yeah,
that we can finish in time for Jayesh to take over. So,
sure.
quick housekeeping. I think my name is Vishal. I'll quickly introduce. So we have on the first talk, uh, we have of course Sagar. Then we have Sudhir Mohanty, Amitabh Prasad, all three from IBM. Going to talk about backup and restore using Velero, and probably going to show a demo in the OpenShift cafe if I'm not wrong. The second talk we have is on demystifying distributed tracing, and this is from a brand new startup called Traceable. Jayesh and Shubham, both early stage engineers and pretty impactful in both the projects, are going to talk about it. At the end of both the talks around 12:15, we'll probably break out into like multiple rooms or a single room to discuss, just catch up on things. Uh, so that's about it. I'll probably drop off around 11:30. I got to get into a customer call, but I'll hopefully be back to chat again with everybody before the end of it. So cool. Over to you, Sagar. Why don't we get started?
Yeah, thank you, Vishal. Sudhir, can you share your screen and let's get started on that?
Yeah, sure.
Yeah,
Let me know my script once my screen is visible.
yeah, it's there, Sudhir.
Yeah.
Yeah, we can get started without and Sudhir.
So Sagar, you want to go ahead or should I start?
You start with and then I'll pitch in.
Hey, good morning, guys. So between three of us, myself, Amitabh Prasad, Sagar Jadhav, and Sudhir Mohanty, will walk you through some of the pain points and the issues related with the Kubernetes backup. Uh, Basically, what we'll do is we'll cover some of the use cases related to backup, restore, and migration. Then we will look at how it is different between in the Kubernetes world versus the traditional VM world, what it used to be earlier. And then we'll move on to see how Velero help us. There are many tools available, but in this session, we'll focus mainly on Velero. And toward the end, we'll have a demo as well. So a little bit about myself. My name is Amitabh Prasad, and I have been working with IBM Cloud for last about 10 odd years. Sorry, ISL for last 10 years. And one sec. Sorry, guys, there's a knock on my door. So yeah, so quickly about this. Let's see. What we'll do is, sorry. So, so when we talk about Kubernetes, right? Like, say, what happens is from last few years, I've been talking to quite a few folks or quite a few clients, and they all have something good to say about Kubernetes. They all say that Kubernetes is a great platform for for running application, but as with any data processing application, there has to be some way, right? Some way to protect my data, and and unfortunately, since Kubernetes is a relatively newer technology, there's a lot of misconception around that. Now, when we talk about Kubernetes, right, like when a lot of time people think that once they have the application running and they can take care of their data, the rest of the pieces can automatically be handled by Kubernetes. But that's a big misconception that we have today, and this is one area that we need to focus on, or that we need to understand what are the issues surrounding Kubernetes, and where all the DR, or where all we'll have the issue where we need to take care of some of the disaster recovery as well as high availability use cases. So when we talk about use cases with Kubernetes, right? Like, so there are three prominent ones that we would like to focus on. And like say one is the disaster recovery, like where we have to consider ways to rebuild our cluster for some reason, like say maybe something happened to the cluster went down, because ultimately cluster is nothing but a set of software running on a VM. So it may have some issue around that. So we need to have some point in time so that we need to keep on taking backup a certain point in time, and should have a ways by which not only we restore data, but application state as well. So that is the use case for the disaster recovery. Now, when we talk about then the second use case that that we need to keep in mind are the data protection use case. So there, what we have is we have to be concerned about data loss, right? Like say, for example, the data may get corrupted for various other reason, or for if at all we look at a certain industry, like the data has to be archived for the data compliance and all and whatnot. So that is the other use case in the Kubernetes where we need to make sure that the data is protected and we should be able to retrieve that not along with the application state. The third prominent use case that is coming up these days is the data migration, and that's where we talk about where we might have to move our data, say between one cloud to another, right? Like say between private to public, or between interoperability between different cloud providers, or sometimes even from public to private for whatever reason. So that's where that migration use case comes into play. And at that time, again, we not only have to migrate data, but also the application state, because Kubernetes ultimately is the stateful application that runs over your hardware. So and the other cases where we need to do some kind of migration is Sudhir, can you just be on the same slide, previous slide, please? Yeah, thanks. So the third use case is like say when we want to move data between various environment, right? Like say from production to staging to testing for various other use cases. Like say in these days we know like we want to ML kind of use case comes into picture quite handy, where we want to move the data around. So yeah, these are the various use cases where we have to take care of, where we have to think about backup, restore, and backup and restore the Kubernetes application. So can you go next? So let's quickly look at or try to understand what is the difference between traditional approach versus having an application in the Kubernetes world. So when we look at the traditional approach, right? So when we are taking a backup of an application, or so application is really when we take a backup of application, at that time we have to take care of uh, of the application running on the server. The server will have some kind of a OS configuration, then some kind of an application configuration, file system structure, and various other things, right? So what essentially we ran into is we backup our backup is very much focused toward the infrastructure way. So if somebody has worked on VMware and they try to move the VM between one machine to another, they can very well correlate with these kind of things, these kind of issues. So basically, again, the focus was more on the infrastructure way, right? Not only just the application. But when we go into the cloud native world, right? When we build application in the cloud native world, uh, in that case, Sudhir, can you go to next? Yeah. So in that case, we have to, there are multiple components that comes into play. I mean, so if at all we think about Kubernetes, now Kubernetes itself, as we discussed earlier, is an application which is more of a stateful operating platform, and it has got certain set of data associated with that. Now, what happens is I mean, there could be a various kind of application that can run on the Kubernetes. Sometime we may have application which is Dockerized, and they might be running on the Kubernetes cluster. And the other cases could be like say you may have a native Kubernetes cluster as well, a native Kubernetes application as well. At that time, application basically knows that. that it takes advantage of all the Kubernetes artifacts, Kubernetes infrastructure, etcd, and all the good thing that comes with the Kubernetes. So in both the cases, the way you take a backup of application will be different. So basically, when similar as at the same time, when we're deploying an application, we are not just deploying. There are a lot of other artifacts that gets along with it. Say, for example, when we deploy an application, we have a deployment resources. Then it may require some kind of a services and various other Kubernetes objects, right? And then there has to be some kind of a interoperability between the two. So there has to be somebody who can underpin this entire application. And once it's created, how do you back it up so that when you recover it, you should be able to reconstitute your application in the same consistent way. And that's where that is what Velero endeavors to do or complete that piece. So before we look into the Kubernetes, Velero, how Velero help us do this, I'll just take a few minutes to look at some of the main pain points or some of the main potential failure points, which happens to which is always there with the Kubernetes application, and that should be accounted for. So if you look into this slide, right? Let's start from the bottommost part, like where we have all we understand know that pod is the minimal or the smallest deployable unit in Kubernetes. So by default, pod are always designed to be short-lived, and it can fail. It may run, it may crash, but at the same time, if at all we have to take account for high availability and DR, then we have to make sure that the number of pod are replicated across multiple nodes, and that way. And then, as far as backup goes, it should be backed up. The definition of the pod should be backed up somewhere in an external source. Moving up the chain, like say, then we have node. So node is nothing but a VM that runs on a physical hardware, right? So worker node fails, and it fails quite often. And to account for the node failure, what we have to make sure that we need to have more than one worker node to run on production. Not only that, also if there are certain application logic associated with the creation of node, like say whatever way you are creating node using some kind of a custom CR or whatnot, then make sure that those CR gets backed up as well. Then as we move up, when we talk about cluster, the cluster availability, that is basically nothing but the Kubernetes master and the main component through which we interact with the other component of the Kubernetes cluster, Kubernetes environment, right? So if the master cluster goes down, our application may keep on running because it runs on the worker node, but then the etcd database is the number one thing that should get backed up. So we'll see a use case of how the backup happens with Velero again. And then there is a zone. Moving up the chain, then we have got zone. Now this zonal failure does happens quite often. So to account for that, you need to have a cluster spread across multiple zones, so that in case zone fails, uh, your application will still be available along with the master node and all. Then region failure is relatively very rare, and if at all you are using your Kubernetes in some kind of a by some kind of a cloud provider, then they ensure that the region is always available. But in case uh, region failure does occur, then you have to account for, like say, how do you back up your cluster with all the appropriate objects and restore it in the other world, in the other region, basically. The last one is the storage piece. That's where we have PVCs and the backed up or application data comes into play. So there are various strategies. Today we'll look at the example of using PV and PVCs, but sometime we might have to think about if at all we can externalize our database and take a backup in a traditional way. So this is just a quick overview of how backup recovery and the pain points of backup recovery in Kubernetes happens. With that, I'll pass it on to Sagar. talk about Velero and take it forward. Over to you,
Yeah,
Sagar.
yeah. Thank you, Mita. Uh, so as we know that why backup and restore and backup and recovery is very important when we talk about Kubernetes and the containerized application. So in the few slides, upcoming slides, we are going to discuss uh, what is an Velero and how it helps us to take backup and restore of a containerized application. So let's quickly talk about the introduction to Velero, right? So it's an open source project and it is formally known as Haptio Arc. Okay, so if you came across this term, it is a Velero nowadays, right? And basically the fundamental features that this tool provides is to backup and restore the Kubernetes cluster. Basically the application which is deployed on Kubernetes cluster, you can backup that, and you can also backup a entire cluster itself, right? Now, when we talk about the components, we have, sorry, when we talk about the components, we have two components here. The first one is the server, and the second one is the CLI, right? So, the server basically a component which runs on the Kubernetes cluster, and for CLI, it's a utility which you can use to communicate with your Velero component, which is present in your Kubernetes cluster, right? So the current version is 1.5.x. So basically 1.5.1 is the current version. So and if you see the GitHub stars, it already crossed like 4,000 stars now, right? So this shows how popular this project is, and slowly industry is also consuming Velero to do their backups and restore, right? And if you wanted to know more about Velero, just you can also go to their website, which is velero.io. Yeah. Sudhir, can you go to next slide? Now, this slide is very important because here we will understand how Velero actually takes the backup and restore. We are going to discuss about the Velero architecture here, right? So the first point is there are two operations, right? Backup and restore. Now, both of these operations are treated as a custom resources in Kubernetes, and both has a CRD. For that, a CRD is defined, right? So basically, if you see a diagram here on the right hand side, what we have seen here is there is a controller. So there is a Velero controller which is deployed in your Kubernetes cluster, and it has different CRDs. So let's take an example of a backup CRD and a restore CRD, right? Now you create an objects which is a backup object or restore object. Okay, so when you wanted to take a backup, you create a backup object. So you can have a YAML return which where you have specified everything like what is the TTL other stuff, right? And then you just execute this command which is like oc apply or kubectl apply -f and the backup.yaml. Now, what will happen behind the scenes? A backup object is created and through API server, which is then stored in the etcd, and then the controller is continuously watching your changes, right? So when it gets a notification that there is an object created of type backup, then it comes into the action and then it will start taking the backup, right? So the gist of architecture here is we have a Velero controller which is continuously watching all the resources which is managed by Velero. And there are two major resources, which is backup and the restore. So both are the custom resources, and for both the custom resources, we have a CRT defined, right? Now, the major advantage of using Velero it supports filtering, and it supports filtering on mostly on the three types, right? So you can filter backup and restore on the basis of type. For example, I only wanted to take the backup of pods, so I can specify type equal to pod. Or I only wanted to take backup of replica set, so I can specify type equal to replica set. So this is one type of filtering. Second type of filtering is you can also filter on the basis of namespace. For example, I only wanted to reach, let's say I took backup of 5 namespace, but then while restoring my cluster, I only want to restore only single namespace. So that is also possible. So while taking a backup or while doing the restore, you can also specify the namespace. So what will happen in that case? All the resources under that namespace will either be backup if you specify it as a backup, or it will be restored, right? And the third one is on the basis of labels, right? Now this is very it gives you very flexibility, right? For example, on my cluster, I just wanted to take backup of the resources which is having label app equal to development, right, or app equal to prod. So that is also possible. So either you can choose, you can independently use different filtering mechanism, or you can choose the combination of it. For example, I wanted to take backup of namespace A, and I only wanted to take backup of the pod type resources, right? So that is also possible. So that's one of the major advantage that comes with Velero, right? And now the third one is the constraint basically. So what happened is, when Velero take the backup, right? Basically, it just copies the data from source and then puts into destination, right? Now to get the data, you know that in Kubernetes we have an API server, which is the front-facing component through which we communicate with Kubernetes cluster, right? And each resource in Kubernetes has this convention of group and resource versioning, right? So the constraint here is Velero will always take the backup using the preferred API version. Okay, for example, let's say there is a custom object, for example book, okay, and the group versions is different. We have library slash v1, then we have library slash v2, library slash v3, but the preferred API version in set in my Kubernetes cluster is library slash v1. So when Velero will take backup of the book resource, it will take backup through that particular API version, right? Now the constraint here is when it will restore that resource into some other cluster, it wants that particular API version to be present in the restore cluster. It doesn't matter whether that is a default or not, but the constraint here is if you take backup through library slash v1, then that API version should be present in the restore cluster, right? That's one of the constraints. Now, before going to TTL, let me discuss a very fundamental thing about Velero is the Velero manages its data, right? Like the data, as in when I took backup, I will create a backup object with some meta information. When I do restore, I have restore information, right? So where Velero manages those data, right? So Velero uses the cloud object storage. So if you see a diagram here, when Velero start taking backup, it is putting all the data to the cloud object storage. I will discuss that in the next point, right? So Velero treats cloud object storage as a source of truth. It doesn't want you to deploy or provision a database for this controller. So what Velero does is it uses a cloud object storage as a source of truth. Now, what does it mean? For example, when I create a backup object, right? So when I create a backup object, so that backup object data will be pushed into the cloud object storage. Now, similar to creating a first backup object, I created 10 more backup objects, right? Now, being an admin, I wanted to know that when I created a backup object, what is the status of that backup, whether it is completed, and what are the logs associated with that backup object, right? So all the data is in sync with the data present in the cloud object storage, or we can say all the data is present in the cloud object storage instead of presenting in your Kubernetes cluster, right? So basically data will present in the Kubernetes cluster in etcd, right? But the same data is also sync on in the cloud object storage, right? Now the advantage of having this syncing is, let's suppose we have a backup present in the cloud object storage, okay, but when we wanted to restore in some other cluster, right, as it doesn't have a backup definition, right? So from where Velero will get the backup definition? So what Velero will do when you install Velero controller on restore cluster and you specify the backup storage location and other connection details, right? It will first go to the cloud object storage and to see whether the backup definition is present into the target cluster or not. If it is not present, it will create the schema or metadata in the restore cluster, right? So then the Velero controller will have access to the backup definition, right? So if you have a backup definition in cloud object storage, and if those definition is not present on the Kubernetes, then Velero will create that definition into the Kubernetes cluster. Now, vice versa. Let's say if the backup definition is present in the Kubernetes, but it is not present in the cloud object storage. But as cloud object storage is the source of truth, then Velero will delete that backup definition of the Kubernetes cluster. So this is the most important point that we need to understand, because when we are debugging different backups and restore, we should know whether where our data is going to be persisted, right? Now the fourth point is related to this only, right? Why? Because here Velero extended its feature, and it asks you to provide a TTL, the time to live, up to how much time you want your data to be present in your object storage, right? Because the data is in the cloud, and then the billing will come, and then you eventually either you need to write your own cleanup project. But the advantage of Weather is it has this provision of automatically delete the data once the TTL is reached, right? So it gives you flexibility to us to define a TTL here. So it's up to you for how much time you wanted a data to be present. Now, when the TTL is reached, there are a couple of data that Velero deletes. It deletes the backup definitions, right? Whatever the data which is present, which is copied as part of backup, will be deleted, and the PV snapshots and other details, right? So then that TTL will take care. So it's a good practice to have a TTL in place. Although there are default value for TTL, but then it is a recommended approach to define a proper TTL as per your need, right? If you are just playing with Velero for your POC purpose, then it is good thing if you set a very low TTL, right? A very like a 1 day or 24 hours kind of thing, right? Now, the last thing here is there basically Velero supports three operations. First is on-demand backup, next is schedule backup, and third one is the restore backup. Now, what is an on-demand backup? On-demand backup is when I created a backup object, right? Then the controller will act on that backup object. It will collect all the data, depend on the filter that you have specified. Let's say if I am not specifying any filter, that means I want a backup of entire application, right? Now, once the data is collected, then that TGZ file or that complete data is pushed into the cloud object storage, right? Now here, the one point to be noted here is this operation is not atomic. What does it mean is when you are taking a backup, when Velero is creating a copy of a data and pushing it into the cloud object storage, it's not an atomic operation. So some other service or some other admin can try to either create some more objects or some more objects are deleted. For example, if I'm taking a backup of all the ports present in the A namespace, okay. Now let's say if the backup process is going on. Now, at the same time, if some other admin or if some other service creates some more pods in the A namespace, so it might possible that for that particular backup, the data is not getting copied, right? So you might seen that there could be some difference in the data which is present in the cloud storage and which is present at the real time, right? Now, uh, this is one thing. Now there is another feature which is common for backup and restore operation, which is the hooks. So there are different life cycle hook that Velero supports. For example, pre-backup, post-backup, pre-restore, post-restore. So let's say if you wanted to do some cleanup, or let's say while taking a backup, you wanted to perform some prerequisites, or while doing a restore, you wanted to do some cleanup, right? So you can definitely use that hooks, and then you can provide your own custom logic throughout the life cycle, right? Now, second is the schedule backup. So we see that in the on-demand backup that the data, as it's not an atomic operation, some data might be left while taking a backup if somebody is doing certain operation, right? Now, what schedule backup does is basically it sets in schedule, or it depends on the cron job. It sets in schedule that it takes the recurrent backup, right? For example, when I create a schedule backup, it will take the first backup, and then it will take the next backup once the cron job, depending on the time defined in the cron job. For example, if I set a cron job that it will take backup after every 24 hours, okay, so then it will take backup. So the advantage of this approach is the last backup will always contain the complete data, right? So the disadvantage that we see in the first approach could be resolved using the second approach, right? Now the third thing is the restore. So what restore does is basically it restore whatever defined in the backup, right? And this restore also supports the lifecycle method. Now there is one important point that we need to understand is, or which is a recommended approach is, when you have started the restore, it is recommended to set the backup storage location as a read on in the read only mode, so that no one is doing any changes on the backup cloud object storage, so that your data is protected, right? No one can edit the existing backup, or no one can delete the existing backup, right? So it's the recommended approach to put your backup storage location in the read-only mode. And once your restore is completed, then you can switch on to the read-write mode. Okay. So that is what I wanted to explain about the introduction to Velero and the Velero architecture. Thank you. Sudhir, you can go ahead with the demo, please.
Yeah, yeah, thanks, Sagar. So before going to the demo, so let me share some information related to Velero installation. So as Sagar mentioned that Velero works on a client server architecture. So in order to deal with the server, we need to install the Velero client first. So there are these are the three ways of installing Velero CLI. So before
Rohit,
installing,
Rohit, क्या तुम
so Uh, okay. Uh, so before installing Velero CLI and Velero server, so these are the three prerequisites. We should have a Kubernetes cluster, and the version of Kubernetes should be greater than equal to 1.10, and kubectl should be installed on that cluster, and we should have a object storage details. So like in which object storage will be storing our backup, and so basically we will be using that object storage for backup purpose. And about installing the Velero CLI, so for installing Velero CLI in Mac, we can use brew install command, and for installing in Linux, we can use the tarball. Okay, and these are the so like we follow the approach for installing any CLI like ibctl CLI or ccli. So what are the steps are required? So like that we need to follow same steps for Velero CLI also. And coming to Windows, we need to install Velero CLI using Choco command. So this is about Velero CLI installation. Yeah. Next is installing Velero server components. So for server also there are two ways of installation. We can use Velero CLI to install the Velero server, and the second method is we can use Velero Hemchat. So Velero, they have created their Hemchat. We can utilize that for installing Velero. So first is how to install Velero server using Velero CLI. So this is the command, okay, to install a Velero server using Velero CLI. And in this command, you can see there are basically there are four things are important. The bucket name we need to specify in which bucket we need to store our backup, okay, and the bucket credential. We need to create a credential file. In that credential file, we need to specify the bucket credential like secret access key and access key ID. And third thing is that the bucket region. So our bucket cloud object storage bucket would be in a specific region. Then that we need to specify, and the bucket URL. So these are certain inputs are required while installing Velero server. And based on this input, Velero will identify the required object storage in which the backup will get stored. So this is how we can install Velero through Velero CLI command. Next is installing Velero using Hemchat. So the Hemchat command will look like this. And here also we need to specify the bucket name, bucket region, and the bucket URL etc. Okay, so next move to demo part. So for demo purpose, we'll be using IBM Cloud. Okay, so in my IBM Cloud, I am having two clusters. One is backup cluster, and another will be restore cluster. And I have an object storage in which I'll be storing my backups. So these are the steps that will be showing in demo. Okay, let me. Yeah, so this is my IBM cloud. Okay, so I have two clusters are there. Okay, one is Velero backup cluster, one is Velero restore cluster. So I'll use Velero backup cluster as a original backup cluster, and in restore cluster we'll be restoring our data or PHP myadmin data from the cloud object storage. So I have also configured my cloud object storage also. So I have created a bucket, storage bucket, object storage bucket inside my cloud object storage. Okay, let me go to my CLI. Okay, so before, let me log into the backup cluster first.
Can you please make the font slightly bigger, Sudhir?
Okay.
Sudhir, can you increase the font?
Just guide me. I haven't actually.
Go to change settings, please. In the appearance, yeah, that's right. I think, yeah, font, change font. The
Sudhir,
change
go
button
to
on the right
font
hand.
setting to see. Yeah.
Just make it 12 or 14, something like that.
Yeah, is it fine now?
Yes, perfect. Thanks.
Yeah. Yeah, so I just logged into my backup cluster. Okay, so I have already Velero installed in my backup cluster. So let me show the Velero pods. Okay, so currently I am in Velero project. Okay, in which I have installed, in which project I have installed my Velero. Okay, let me show the pods. Yeah, you can see I have one Velero pod and one Restic pod. So these pods are responsible for Velero. So these are the components for Velero. Okay, so before taking backup, let me show you what are the backups already I have in my storage bucket. Yeah, you can see there is a backup named PHP myadmin Sudhir. Okay, so this is already there, and you can see when it is created. Now let's go ahead and install our PHP myadmin app. And after installing it, let's add some sample data into that application. So I have a PHP myadmin app. I'll be installing that app using HempChat. So I have a demo project. Okay, in that demo project, I'll be installing my PHP myadmin app. Let me go inside. Now I'm in demo project. Let me see the PVC first. Okay. Yeah, now you can see I have two pods are created. One is in pending state, and that is due to PVC. My PVC is not created yet.
Just a quick reminder, Sudhir, just to let everybody know, when we talk about project in OpenShift, what it is similar to namespace in Kubernetes, or it is same as namespace in Kubernetes.
Okay.
Yes, there it's like previously might they created on the Velero namespace. Looks like.
Yeah, somehow PVC is not created, hence this pod is not coming
No,
up.
the PVC is created in the Velero namespace. If you see, it should be created in the demo namespace.
Okay, not sure how it is created. Let me delete. Okay.
And leave it there. You can just create one more here, right? This namespace.
In
Okay.
the just apply the PVC YAML in the demo
Yes, yes.
namespace. No, it's already there in your file system, right? Just apply it.
Yeah, let me take it here.
And then
Need to- just a second. Okay, let me use this.
just apply this YAML. Sudhir. It will be created in the demo namespace.
Okay. Yeah, now it is created and in trending state. Okay. Yeah, so once the PVC will be created, then the Debbie pod will come up. So let's wait for some time. So the PVC is provisioning the PV. It will get provisioned dynamically in IBM Cloud.
Meanwhile, Sudhir, you can explain the Velero backup command just to save the time here.
Okay, so once the application will be ready and we'll be adding some data into it. So before taking the backup, we need to add certain annotations to the pod. The pod which is using some certain persistent volume. Like in case our DB pod is using, let me. Okay, so this is the DB pod. So you can see this DB pod is using a persistent volume, and the volume name is DB data. So according to Velero, so there are certain prereqs are required before taking backup. We need to add certain annotations to this particular pod, the pod which is using any persistent storage, and the annotation should be like. Uh, So this should be, we should add this kind of annotation. Okay. So currently this pod is having one persistent volume and the name is DB data. So we'll be adding this annotation and we'll specify this volume name as this. If there will be two persistent volume, then we need to specify the volume names separated with comma. So after adding the annotation, we need to create our backup, and our Velero backup command will be like this. Okay. And suppose I want to take my demo namespace backup. Okay. Velero create backup, then include namespaces, and the namespace name will be demo. So let me see what is the status of installation now. Yeah, now you can see my pods are running fine. Okay, let me access this application and add some data into it. Before that, I need to create my route. Okay. To access this in browser, let me. Okay. Yeah, now I got the URL for my application. Let me log in into that application. Yeah, so my credentials. So we'll add some sample data so that after restoring the application, we can see that our data is restored. Let me add one database named customer DB. Okay. And in this database, I'll be adding a new table named customer. Suppose I'll make the number of columns will be 4. Okay. I'll add customer name, email, address, and I'll add a column name credit limit. Okay. I'll keep it. Okay. Yeah, so now I have created a table in named customer. Let me add some data into it. Okay.
So there one entry is sufficient. Let's proceed.
Yeah. Just, yeah, so I have some data in my table. So you can see two rows, two sets of data are added. So now we are ready to take the backup of this application. So as I mentioned, so before taking the backup, let me add the required annotation. Okay. And this annotation is very much important. Otherwise, there will be some issue with data backup and restore. Okay. Let me create the backup. Now I'm creating the backup. And my backup name I have specified as PHP myadmin name, and I'll include the namespace. So this is how my backup command will look like. Let me execute it. So now you can see that we got the successful message, backup request is submitted. So now Velero will be responsible to carry forward this request and to take the backup. Let me show you the backup. So using this command, we can list all the backups. Now you can see the backup request we have submitted just now. It is in progress state. It means the backup is getting created. So once
So
our back,
for the interest of time, can we use the previous backup and restore the application? Quickly show how to do restore.
yeah, sure.
Yeah.
We can see the backup is also created. So let me. So now we are done with backup cluster. We need to log into the restore cluster, because in restore cluster we'll be restoring our app from the backup. So let me log into the restore cluster first. Okay. Okay. So now I am logged into restore cluster, and in this restore cluster also I have installed Velero and configure with the same storage bucket. So let me retract the backup first. Okay. So these are my these are backups we are having. Okay. So we'll be restoring the backup, the application from the backup. So currently the demo namespace will be not there. Okay. Let me show you. You can see no projects with this particular name. Okay. Now we'll be restore our application. Okay. So let me. This is how my restore command will look like. Velero create restore and the restore name, and from which backup I need to create my I need to restore my application. Okay. Now the restore request is submitted. So let me show you the Velero. So you can see now. Let me go inside the project a demo. Let me see what are the objects are getting restored. Yeah, now you can see everything is restored. The pod is in pending state because the PVC is getting created. Let me show the PVC. Yeah, it is in pending state. Okay, so it will take some time. In the meantime, let me do one thing. So now you can see the route is as we have restored the route, it is pointing to the backed up cluster. You can see in the URL. So let me do one thing. Let me delete this route and create a route again, so that the route will be pointing to the restore cluster. Yeah, I have deleted the route, restored route. Now I'll create the new route, okay, which will be pointing to the restore cluster. Yeah, my route is created. Let me see the PVC status. Yeah, even the PVC is created. Let me see the pod status. Yeah, it's getting created. Let's wait for some time. So yeah, now it is running. Okay, so now we can access. We need to access our restored application, and we need to see whether our datas are getting are got restored or not. So let me log in. This is the URL for the application which we restored now. Yeah, so now you can see here, we have the customer DB, and we have the customer table that we had created in the backed up cluster. And we have the data that inserted into that table. So now we can see, we can say that our data are got restored from our backup, from the cloud storage. So this is how the Velero backup and cluster backup and restore will work actually. Yeah, this is all about the demo.
Yeah, Vishal. So we can hard stop here, and then Jayesh, you can take it forward, and let's take Q&A
Cool.
at the end. Yeah.
Yes, sure. Yes. Just share my screen. Cool. Uh, so good morning, everyone, and thanks, Sagar, for our previous session. So we will start with the next session, distributed tracing, and I'm so I'm Jayesh Bapu Hive, and currently I'm founding engineer at Traceable, where we're building a modern AppSec platform based on distributed tracing and machine learning. We also have open source or underlying platform called Hypertrace, and it is a real-time observability platform. So apart from my day job, I'm also involved in some AI research, and I have been working around distributed neural computers since past 2 years. So if you want to chat with me around my work or collaborate or discuss on some projects, you can find me on Twitter at Jayesh_11. And we have my colleague with us, Shubham. Shubham, you want to introduce yourself?
Hey everyone, I'm Shubham. I'm also founding engineer at Traceable with Jayesh. I work as a full stack engineer, so I get to work here at different technologies, Kubernetes, GraphQL, front-end Angular stuff. And being a full stack engineer gives me an opportunity to be an enthusiast in many languages or many technologies. So I like to be a JS enthusiast, and I'm also one of the speakers in the JS meetups in Bangalore. And you can reach out to me on Twitter at skjingle93.
Cool. Thank
Over to
you.
you, Jayesh.
Yes. So let's go through the agenda for next 25, 30 minutes. So we will see why observability became important and what is it. Then we will discuss in particular about distributed tracing, and then we will see a demo of an application distributed tracing with Hypertrace. So let's jump into our first broader point, observability. So monitoring or traditional APM solutions have been around from quite some time. And as this code says, that monitoring tells you whether your system is working, and observability lets you ask why it is working at any particular point. And most of the times, why is very important in most of the cases.
And it's really important here as well. So we will first discuss why we need observability, or why you guys need observability for your products. So there are so many reasons around it, and let's just walk through a thought process which will help us understand these reasons even better. So most of the tech giants, including companies like Amazon, Netflix, Google, started to build their systems using monolithic architectures because back in the time, it was much faster to set up a monolith and to get the business moving. And the priorities were different. The priorities were just getting your business moving at the first place. But over the time, as product matures, or as we say, fat growth happens, with growing systems, the code also gets more and more complicated. And they all faced this problem and looked at microservices as a solution. So one of the biggest benefits of microservices was that you can develop, deploy, or scale each microservice independently or separately, and you can even replace or upgrade any part of the system independently. So everyone started adapting to this microservice architecture, and now we are looking at very complex architectures and complex modern architectures in multiple companies and multiple organizations. So one of the benefit of micro, so if you want to look at some of the complex architectures, you can just take a look at this Dead Star diagram, which shows microservice architecture at Amazon and Netflix. So one of the benefit of working with older technologies like monoliths was a limited set of defined failure modes. Yes, things broke, and they broke all the time, but you pretty much know what broke at any given point because there were predefined common failure modes which you can identify clearly and which you can fix it. So as systems became more and more complex, the possible failure also became more and more abundant. And like we created monitoring tools to help us figure out what was going on in guts of our software. But it got really complex over the time. Like we were monitoring performance using data collection and then time series analytics, but over the time it becomes hard to manage, and it gets quickly out of the hand. So when you look at the modern systems, with everything turning into open source cloud native microservices which are running on Kubernetes clusters, it is extraordinarily complex to manage these things. And even going further, they are now being developed faster than ever, like between CI, CD, DevOps, agile development, progressive delivery, and all these fancy terms. The software delivery training is also speeding up. So with those very complex distributed systems, which are being developed at speed of light, the possible failure modes are also multiplying. And when something fails, like previous days, it's no longer very obvious that what caused it. And we cannot keep up with this by simply building better applications. Like nothing is perfect and everything breaks at some point or fails at some point. And the best thing we can do as developers is just to make sure that whenever our software fails or our system fails, it's as easy as possible to fix it. But unfortunately, many modern developers don't know what the software failure modes are. And in many cases, there are just too many of those usually. And sometimes we even have unknown unknowns in our software or unknown unknowns in our system. So we don't put effort in fixing some problem because we don't know that problem exists in the first place. And when you look at something like standard monitoring systems, or standard monitoring, like the something that happens after release cannot fix this problem because it can only track known unknowns. Tracking KPIs or reporting your performance, it's only as useful as that reporting accurately represents your internal states of the systems, or it can help you determine failure, which might not happen in most of the cases. So we can say that your monitoring is only as useful as your system is actually monitorable. And this concept of monitorableness of your system has a name, and we call it observability. So when we want to define observability in a control theory, observability is defined as a measure of how well internal states of your system can be inferred from knowledge of the system's external outputs. So simply putting, observability is how well you understand your complex system. Then metrics, events, logs, and traces, or as we call them, MELT, are the core of the observability. And but usually it's a whole lot more than just that data. So if you consider the process of placing an order on Amazon or Flipkart and it failed due to queue timeout. So what are the characteristics that queues that timed out at 500 milliseconds share in common? Maybe service versions, maybe browser plugins. So in this case, or maybe some other stuff as well. So in this case, instrumentation basically provides you data, and queuing that data answers your question about your systems. And when you talk about collection of a data, telemetry comes into a picture. Telemetry or collection of a data from instrumentation is very important when it comes to observability, because data is what's aiding observability, and that's why like indirectly telemetry aids observability. But we also have to keep some things in mind, like telemetry data isn't observability itself, and instrumentation code is how we get the telemetry. So to aid observability use cases, your application needs to be instrumented in the first place, and telemetry data basically describes your events events in the system. So it usually provides you a different view into same underlying truth. And usually it gives you data like metrics, logs, and traces. So let's talk about metrics, logs, and traces, which will simply pay our way into talking more about distributed tracing itself. So when you talk about MLTs, they are basically called as a golden triangle of observability monitoring. And talking about first thing, metrics. So metrics are basically aggregated summary statistics, and they are so valuable because everything from your operating system to application generates metrics, which at the least will contain a name, a timestamp, and a field which represents some value. So since so many resources are coming together and readily available to tell us about themselves, metrics is the first obvious place to start when it comes to anything about monitoring or observability. Whereas logs are detailed delivering information emitted by processes. And logs are perhaps the second most important tool in the monitoring toolbox, because virtually everything logs information about what they are doing at any given point. And other than that, logs tends to give you more in-depth information about resources than metrics. And like so, metrics is showing that some resources dead, logs will help you understand or tell you about why it died in the first place. And our focus for today, like the third one, traces or distributed tracing. It provides us insight into full life cycle of a request to our system. So traces allow you to pinpoint failures and performance issues. And with so many application interdependencies these days, there's operations will typically involve hops to the multiple services, and these hops are what we call generally spans. So traces basically add like a critical visibility into the end-to-end health of the application. Like they are fully focused on the application layer and provide very limited visibility into health of the underlying infrastructure. So if you collect the traces, you still need metrics to get the full story of your environment. And APM tool basically feed trace information to a centralized metric store. So traces provide a nice source of data for an app-centric view. And the structured data can be transmitted into any the structured data you get from telemetry can be transmitted into any of this, and all of them like metrics, logs, and traces hold their own importance in their own ways. So everything is important, but like it's all about how we use that data, or how we link that data and like develop more understanding out of it. Cool. So let's talk about distributed tracing. Like that is what we were here for in the first place. And like before we start about talking about distributed tracing, like let's go back to previous days when I was talking about monolithic apps. So the monolithic application, like the Java application here, it's a in here like user client sends some request or web request, and perhaps it passes to a load balancer to a web application or server. Some database transaction happens in the backend, and then the response is generated and it get back to client. So there are hops in this entire process. Like this request is passing through multiple services, but still it's a very linear path. And it's quite possible to instrument each of the hops and visualize the state of the transaction, and even understand the performance of each of the step, each of the step or each of the service when the request is passing through this monolith. It's quite easy. But when we talk about modern distributed systems, it basically comprises of several microservices. Even in this diagram, it's less, but usually it's more than thousands of microservices coming together. And it forms a very complex entity. A transaction may pass through multiple services, maybe 2 services, 3 services, 5 services, hundreds of services. And it can trigger multiple database transactions. It can go back and forth from one or other service. And it basically it's a very complex interaction happening all around the place. And here the path of the transaction is quite different than what usually is. Like we have uh, in this case, like in this example itself, we have assumed that our system is located into a single virtual entity. But usually that's not the case. Like your one service may be in a different zone, and uh, second service might be in a different region. So this different region interaction also build up latency. So you have to you have to consider latency. You have to consider various parameters in mind when we are talking about observing these complex systems. Okay, so the main problem with this very complex architecture is lack of clear linear path, and this one thing makes it very challenging and tedious to track the transactions happening throughout the system. It's often hard to map a client's request for transaction since there is no single service interaction happening here. There are multiple services which come into picture, and there might be some bottlenecks happening at any service. Like maybe if you consider just a single just so example of placing an order on Uber. In that case, suppose like hundreds of services are getting triggered for each of the requests you are uh, each of the ride requests. Then in that case, maybe payment service has some bottleneck, and that's why your whole process is being slower. Maybe pairing service for the ride is having some bottleneck or performance issues, and that's why your whole system is slow. So this identifying these bottlenecks is also important when it comes to monitoring or observing this huge complex systems. So okay, how distributed tracing is going to help here? We understand that okay, this is a problem and there's a and we need to solve it, but how it will help us here? So tracing tracks actions or events inside your applications, record their timings and collecting the other information about nature of the action or event. And as I said, you basically need to instrument your application to generate traces or to all of the other data as well. So trace is basically a request. Trace basically tracks your request end to end when it passes throughout your system, like what services it's hitting and what time each service is taking for that request to process or what is latency at each point, and then uh, timestamp for each of the service. This a bunch of the information comes into picture when you are considering one single trace or when you're considering one single request and response cycle. So okay, then what basically is distributed tracing and how it will help us going ahead? So distributed tracing tracks production requests as they touch different parts of your architecture across time. And each of the requests will have unique ID, which you can use to look up a trace diagram or log entries related to it. And this casual diagrams will help us understand your system better than scrolling through a bunch of logs. And what are some of the concepts related to trace? So there's a span, which is like a primary component of a trace. A span represents an individual unit of work in a distributed system. So span usually have a start time and end time. And first span in the request is called the root span or parent span, and all the subsequent spans are called the child span. You can look at this. Uh, a trace constitutes mostly more than one span, and in the example we consider of the microservice architecture, there were multiple requests and multiple interactions happening, so there will be multiple hops throughout the system, and the spans are linked together via trace ID, and this makes it possible to build a view of a complete life cycle of a request throughout as it propagates throughout the systems. And span can also have a user defined annotations in the form of tags. So it allows us to add metadata to the span to provide assistance in understanding where the trace is, where the trace is coming from, and so help us understand context in which it was generated. And you can even attach logs as a key value pair to a span, so it can carry those as well. And it's very useful for informational output from the application, and it sets some context or document some or help us in documenting some specific event. So as I said, this is a general representation of a trace and trace structure as per the open tracing documentation. And okay, so why should you care about this whole thing in the first place? Why should you care about distributed tracing in the first place? So as I said during the why observability thing, that system change all the time and things fail in very unexpected ways. And in general, like there are many unknowns in modern distributed systems. Most of the problems converge at the, are the convergence of the many different failures or very different things failing at the one point. And everyone on the in the team should be on the same page about level of understanding. They know what is happening in the guts of your software when they are on call. And what are the answers you get out of distributed trace data? So it provides you what services did a request or message pass through, what occurred in each service for a given request or message, and where did the error happen, where are the bottlenecks, then what are the critical paths of the request, and who should I page or who should I blame when failure happens. So this is a general trace this is generally how trace looks like in a real world application. Uh, this is what we have generated in Hypertrace using Trace Shop. And here you can see this is the first one. The blue one is your parent span, and all the subsequent others are the interactions happening throughout the time it propagates to the system. And it actually represents the different service interaction into different colors, so you can see that how they like. If it is into a payment service, it will be a different color. If it is to a recommendation service, it will be a different color sort of. And you can see the latency here as well, like how much time it takes to process to like pass through one particular system. And if some service one particular service, if some service is taking more time than expected, like you are expecting that process to happen in 100 milliseconds and it goes to 300 milliseconds, you can basically say that there's some performance optimization we need to do there, and you might go ahead and work on that as well. So yes, that was basically all about distributed tracing. I will hand it over to Shubham for a demo and a brief intro about Hypertrace. So over to you, Shubham.
Thanks, Suresh. So I hope everyone understood the theory around it. Let's jump into the demo. Yeah, we call our distributed tracing platform as Hypertrace. And yeah, as the name says, it is a platform, observability platform. It covers all your metrics, transactions, and gives you visibility into different services, APIs into the system. So to brief what Hypertrace is, it converts distributed trace data into relevant insights for everyone. So in a team, like if you have infrastructure teams, they can identify which services are causing overload. Application teams can understand which requests put their service objectives at risk. And deployment teams can know if there is some problem that has arisen because there is a new version that has been deployed. And the beauty of Hypertrace is it accepts all the major tracing data formats, be it Acre, Ripken, Hotel. So which means if you have distributed tracing enabled already in your system, you can just try it without changing an application at all. You can just pump your traces into our system and look at Hypertrace. So we created Hypertrace at Traceable and open sourced it. Now the community is helping us to make this the best observability and distributed tracing platform out there. So over to demo. Yeah. So this is our GitHub. So github.com/hypertrace. And so please go and I would request everyone to please go and start the repo. You can actually clone and test it out in your local system as well. In order to test it out, you can actually, we have an Hypertrace properties.file where you can use any Kubernetes context like Docker desktop is by default, but you can change it to things like maybe Azure or Minikube or something. And yeah, it picks your STCube context by default. Okay. And if you want to try it quickly without doing all this Kubernetes thing, we have a Docker Compose config where you can just use this Docker compose.yaml. It will directly spin up the application in your local system. And that's about it in terms of deployment. And you can use, we have this LoadGen app, which is a very cool e-commerce kind of an app, and it is built on different languages, built on different languages. There are multiple services running behind it. So there are Java services behind it. There are C++ services, Go services. So it's a good blend of different services, which actually simulates a real world application. And the way this e-commerce website works is just like any other e-commerce website. Like you can actually add to cart and then place an order, and your order is complete, and then you can keep browsing, add more items to your cart, and then so you can keep doing that. And since there are many services running behind this, it will keep sending traces to Hypertrace, and Hypertrace will be able to actually show you a good visibility diagram around it. So yeah, let's jump into how Hypertrace looks at. So we have that LoadGen application pumping traces into Hypertrace. So this is how you are welcomed in the dashboard. On the dashboard, you see many things like what is your P99 latency in the last 15 minutes. So how does your latency of your entire application was working across services? And you can see some spikes in it, and where you can actually go and debug. You can go to the time range selector, change it to last 30 minutes, 1 hour, and see the data how your application was behaving in last 1 hour. And we automatically identified different sets of entities. You don't have to do anything in your application. So different sets of entities, like what are the different APIs in the system. So here are top 5 APIs into your system with their average latency, errors per second, number of errors, calls per second, calls, and similarly service at the bottom, and backends. And yeah, we have these cool graphs for you. So here we show you the topology of various services into your system. So it says that front end actually calls checkout service, which also calls product catalog service. And on every service, you can hover and see how much different metrics we have captured, Hypertrace has captured. So we have P99 latency, P50 latency, which is the median, error percentage, error count, call rate per second, call count, and so on. And similarly for every services. So this view actually gives you a nice insight into your application of how your services are connected to each other, how they are talking. And once you go to the services, you can actually see a list of all the services within the last hour, look at an overview, and there are different metrics which this dashboard contains. So one of the cool things is we are also able to tell like which service is talking to which, all the APIs in it, and how much time again and all the metrics it is taking. These are all the top endpoints, and different sets of metrics around how does your P99 latency behaves, errors per second behave, calls per second behave in the last car. Similarly, every service, if you see a system, if you see an application has list of services, and then every services has list of APIs. So we call APIs and endpoints interchangeably. Here, you can actually see these are the list of endpoints discovered automatically from the traces. And for every endpoint, there are these different cool set of metrics. You can click on an endpoint and see an overview again, just like there was an overview for services, and you have cool Cartesian graphs. So let's come to traces, which Jayesh was talking about. Now, whenever you make a call to any of the system, any of the services in your application, there is a trace that is being formed. And usually a trace means there is an API call to a service. So a trace usually starts from an API call. So these are all the traces which started from this particular API call in the last hour. So for example, you can click on a trace and then actually slice and dice, looking into what took most of the time into that particular transaction. So it went into front end product catalog service. You can see it spent like 915 milliseconds over there. So you can actually see if that was the expectation, or it should have taken less or more. And you can also see a full trace, because there can be some more transaction happening before. Here it is just showing it transactions starting from that particular API, but there can be multiple APIs before that where the trace was actually started. So C full trace actually gives you a view into the entire trace, including all the APIs. And here again, you can slice and dice based on what API was called on which service and how much time it took. So for example, this particular API call into this particular service took around 1.5 seconds. So you can again think about whether it should be investigate why this was taking 1.5 seconds. And that gives you a nice visibility into your system. And similarly about this around 1 second. So, and now we also have a overview about metrics of an API. So this is a cool screen where you can actually see different sets of charts where you can see latency chart being built for median, P95, P99 average. We have errors on the right. We have calls per minute in the bottom. And yeah. So let's come back to services again. And services, we also have traces within a service. So before I showed you that there's a traces starting with that API, these traces would mean the traces of all the APIs in that service. And this is actually a global view of the entire traces in that service. And there will be a lot of them because there were lots of APIs. And you can do the same thing again. And you can also slice and dice by saying, give me all the traces where the duration is, let's say, greater than 300 milliseconds. And it will give you just the traces which took only greater than 300 milliseconds. And you can again slice and dice investigate those and see where is the problem or not. And you can add other many sorts of filters, like give me all the traces which were only HTTP, the duration is greater than 300 milliseconds, and the API name was this, and the status code was error. So it has a flexibility of you giving slicing and dicing on different sorts of columns. And again, you can click on a trace and identify what was the bottleneck for that particular trace and what was the API and service hogging the trace. Yeah. And similarly, we have the metrics for the entire service as well. So different Cartesian charts of different metrics like latency, average, latency, errors, calls per minute, and so on. And we also identify what are different sets of backends into your system apart from APIs and services. So backends are like the terminal things on your trace, because every trace has to go and store some data or get some data from backend. So there were two backends in the system. One was MySQL and Redis, and it's again the same view. Now we have a cool Explorer screen where you can actually slice and dice into anything. It shows you traces of everything into your system, and you can put filters on any of these columns. You can say what was the end time, calls, duration, error count greater than something, start time less than something, status code, failure, and so on. So let's try putting a filter on protocol being HTTP and see all the traces which were just HTTP traces. And again, you can like add the filter, remove the filter, add whole lot of filters, like 10 filters where it says protocol equal to HTTP, error code equal to failure, duration greater than 20 seconds, and so on. And this was the span which Jayesh was again talking about. Like span is a smallest unit of measurement in a trace. So these are all the list of spans. Again, similar, the set of filters are the same. You can get the smallest unit of work and see by what are my spans which are taking more time, or what are my spans which are erroring out. And you can do this for any sort of time range, last 15 minutes, last 1 hour, last 12 hours, last 2 weeks, last 1 month, depending on your retention period. And you can also put a custom time range. Like, for example, let's suppose I just wanted to look at a custom time range for say last month, from particular date to particular date. I'm just interested in that because there was, let's say, a Black Friday sale going on or something. So how was my application behaving at that time? You can again do a slice and dice of everything. And yeah, that's about it in terms of the demo for Hypertrace. In in order to summarize what Hypertrace gives you, it gives you a very cool topology of different services connectivity, APIs connectivity in real time, and it is really scalable for hundreds of them. And I already showed you different cool dashboards around service overview, service metrics, API overview, API metrics, backends, traces, and so on. And we have built it in such a way that it is extensible. Like it is really extensible if you want to add more data into your traces. Like for example, we ourselves add things like APIs and backends. But if you want to add a different entity into your system, it's very simple. You just have to write an enricher and it will create an entity and start showing it and put it on the UI. And as I said before, it works out of the box with all different tracing formats like zip and hotel later. And we have a system where you can actually also detect different GraphQL APIs. So GraphQL works over HTTP, but they have a different concept. So it can also differentiate between HTTP APIs, gRPC APIs, and GraphQL APIs. So you can actually see how your GraphQL APIs are performing as well. And the Explorer screen I talked about, you can do all sorts of analytics, slice and dice on different filters. And the backend we use is Pinot for the time series data storage. So all the filters you see on the Explorer screen is backed by Apache Pinot. Yeah, so this is the Hypertrace project. I'll just request you to go and start it again. And yeah, that's about it. If you have any questions, you can find the Google Slides and you can join the Slack community here. This is our link to the Slack community, and this is our QR code for access to the Google Slides. Yeah. Yep. Different blocks if you want to investigate into different. So these are like different things if you want to investigate into your system, just see how distributed tracing work. And yeah, you can use this link. So thanks. Any questions? You can find Jayesh at this Twitter and me at the Twitter I mentioned in the beginning slide. Yeah. So thank you. Thanks everyone.
I guess Vishal is also back. Are you there, Vishal? Cool. So thank you everyone again. And if you have any questions, you can. Oh, okay. Vishal is here. Okay, cool.
Hey, thank you so much, Jayesh, Shubham, Amitabh, Agar, and Sudhir. Thanks for really walking us through the details. It was at least I found the first session super useful. Definitely, I'll catch up on the recording of Jayesh and Shubham later for sure. Cool. All right. Anybody has any other questions? Yes.
I guess only we are. Okay. Only we are here.
All right. Thanks everyone for joining in, and hope to meet again virtually in a month or so.
Yes,
Yeah,
that's new now.
Yeah.
Maybe I
Thanks,
will
Jayesh.
ping you if I'm. Hey, Sagar. Thank you. See you. Maybe I will ping you if I'm in Pune next month or this month.
Yeah, let me know, Jayesh.
Cool. Chalo. Have a good day. Have a
Yep.
good weekend.